Can I?
Niti, ma'am, you can start.
Shall I start? Okay.
Yes.
A very good afternoon, one and all present here. I welcome all the participants to this two-day International Conference on Advances in Renewable Energy and Electric Vehicle 21. This session has been organized by Department of Electrical and Electronics Engineering, SIRT. And after the keynote lecture, this is the first presentation. After 1:30, we'll be having lunch around up to 2, and at between 2 to 3, we'll be having another keynote lecture. So please go ahead for the presentation one by one. As we have our presentation committee has been arranging the participants one by one, already been shared. So I request our first participant, a group of 4 students, Kumar Raj, Aisha, Ishan, and Abhay Kumar from 8th semester. Department to please present, go for your presentation. Kumar Raj, I invite you to please present your PPT.
Thank you, ma'am. Good afternoon, respected.
Is there? Okay, Aisha.
Today we are going to
Good afternoon.
present.
Aisha, your voice is a bit low. If you can.
Now, I'm audible, ma'am.
Now, perfect. You can. You are audible.
Today
Go
we are
ahead.
going to present on home system, and our guide is Professor C. Rajput, ma'am. And I am Aisha Siddiqui, and my team members are Kumar Raj, Ishan Soni, Abhay Kumar. Now I am going to explain about our content. Next, our project idea, IoT, component required, working and block diagram, applications, advantage, disadvantage, conclusion.
Excuse me, boss. You have a text message.
Difference. Now, next. Now I am going to explain abstract. In this project, we are made a home automation system with the help of IoT. Prototype and implementation of smart home automation with Wi-Fi technology are demonstrated. ESP8266 is used as a Wi-Fi technology. The system consists of hardware and software interface. In the hardware interface, the integration of ESP8266 Wi-Fi technology for controlling home appliances and sensor is manifested, and an application is provided for controlling to multiple users of home with smartphone, tablet, and laptop and voice. The system is one of the best method for controlling home devices with easy with multiple users, and one of the best method for an energy management system. Next. Now comes to our project idea. I am going to explain our project idea. We are made a smart home automation device. With the help of this device, we can easily control the home appliances like TV, fan, AC, motor from anywhere with the help of a smartphone and voice control. Now comes to IoT. Basically, in this project, physical devices connected with internet, and IoT is a platform which provides us lots of things with which while other internet, and IoT provides the status of each appliances is viewed in mobile from anywhere in the world. These are the components which we are using: Node MCU, ESP8266, SIN, software, relay module. Next, these are the software which we are using: Amazon Alexa, Synric, Arduino. Next, now comes to Node MCU is a module with the help of this module we provide connectivity to our devices. Next, These are the features of Node MCU 8266. These are the relay module. This relay module acts as a switch. Next. These are the features of relay module. Flow diagram. These are the flow chart. Now I explain. When I provide input with the help of voice and smartphone, then signal is received by Node MCU, and Node MCU execute then signal, and output is going to relay module. We now back. Android phone and laptop is connected with internet, and it gives signal to Node MCU. And relay module receive the signal, and it sends signal to our device, which easily switch on off the on our devices. Next, these are the circuit diagram of Node MCU. Next, now comes to figure first, when there is no connectivity in Android phone. Next, now comes to second figure, when there is connectivity in Android phone and Node MCU. Now comes to figure third, when there is connectivity with Wi-Fi in Android phone, and also we provide signal from our phone, then it gives signal to Node MCU, which turn on relay board and give signal to lamp. Just because of signal, it switch on the lamp. Next, these are the applications. This project can be used in home, industries, office, shops. These are the advantages: reduction of time, efficient, easy to use, quick response. These are the disadvantages: cost effective, human effect, and dependent. Next, these are the which in turn helping us to make our life simpler and more comfortable. It gives basic idea about the controlling of home appliances, provide a security using Android. These are the references. That's all about our presentation. Thank you.
Okay, thank you so much, Aisha. I request it was the next participant to please share their screen. Second is Amit Verma and group. Amit Verma, Ashish Kushwaha. If you can please share and give your presentation. Okay, yes, Amit, your presentation is visible. Very nice. Go ahead. You can maximize your presentation, Amit.
Ma'am, am I audible now? Am I audible, ma'am?
Yes, yes, Amit, you are audible, but your screen share has been just a minute ago. It was visible. You please share your screen again.
Yes.
Maximize this.
Now it is
Yes.
visible, right?
Yes, yes. Go ahead.
So good afternoon, everyone present here, and today we are here to present our major project we have took for the presentation, and along with my members, Ashish Kushwaha, Ajit Alam, and Preeti Kumari. And the project is human sanitization and disinfection system for tunnel system for protection against COVID-19. And it is guided by Dr. Shifali Jain. And if we look to the current scenario, there is an outbreak about the pandemic, and it is the most recent consent of our what we can concerned about. It is a very relevant topic to be discussed. And so, as we undertook this project, and so let us take a brief overview what it is about and what it takes to make this project. So, first thing is, as we all know that we are dealing with COVID-19, and this COVID is transmitted through respiratory system. And though we are going online, the things are going online, but there are certain things which we cannot go for online. And these are specifically medical terms such as hospitals and shops. Those are needed physically, and those have physical relevance in this world. So we cannot skip those. We need proper sanitization for that, and that can be done by our that can be done by our project, that is human sanitization. What all need is that what all things we need in this project is can be discussed by the functional blocks, which is namely SMPS, controlling element, and sensor element. We'll discuss it later in block diagram. First, we will just look at what it is uh, about. So this is our in this diagram, we can look that it is a framework which has a PIS sensor and a control, which is our sensing element, and the other parts, which is nozzle, tunnel, and sanitizer tank. So what will happen as soon as the person enters this the sanitizer tunnel, the sanitizer spray will come into existence, and it will spray the mist of vapors and disinfectant medicines, which will sanitize the person, and the person have to wait for 30 seconds to come for the complete sanitization process, and thereafter he or she can move out. So this project can be implemented where the person where is there is a need of frequent exit and entrance, such as hospitals and shopping complexes, for example. And this is a powerful disinfectant system for the disinfection. Now let us look about the block diagram. So it is a very simple block diagram. It has SMPs, control element, sensing element, and sanitizer dispenser. Sanitizer dispenser is nothing but the pressure pump which will spray the mist of disinfectant and medicinal solution. So these are the three major components which we have to discuss. The first thing is SMPS. SMPS is usually supply the power to the controlling element, and relay also, which we'll discuss in the circuit diagram. And the controlling element controls all the processes which will be needed and guided to the project. Sensing element will sense the motion of the object, and here controlling element is our Arduino, which is the hardcode member of this project, and this will be required to dispense the solution. Next, we will look the circuitry components. The circuitry components are the pressure pumps, dispenser, as I said. Power supply is nothing but SMPS, switch mode power supply, which is needed for the voltage, whatever voltage we required, it just switch that. And PIR sensor is our sensing element, and Arduino is our Arduino. Here we're using Arduino Uno, which is the controlling element of. Rest all the things are the supporting things which are required, such as relay, electrical cable, diode, transistors, flask, and there are some non-circuitry components which will constitute the framework of this project, such as plastic tank, pipe, bottle nozzles, connectors, etc. That's now I would like Ashish to give the brief circuitry about the of this project. Ashish, please, this over to you.
गुड आफ्टरनून एवरीवन। तो ये सर्किट बनाने के लिए नेशनल सॉफ्टवेयर का यूज़ किया है। तो इसमें हमने एसएफपीएस मॉड्यूल लगाया है, साथ में आर्डिनो यूनो है, पीआईआर सेंसर है।
आशीष थोड़ा
relay
वॉल्यूम, बेटा थोड़ा वॉल्यूम अपना रेस कर लीजिए।
मैम अब ठीक है? हेलो मैम।
ओके ओके,
तो
yes it's fine, go ahead.
एसएमपीएस लगाया है, आर्डिनो यूनो लगाया है, पीआईआर सेंसर लगाया है, रिले लगाया है, ट्रांजिस्टर लगाया है और रजिस्टर और एक पंप लगाया हुआ है। तो जो पीआईआर सेंसर का आउटपुट वाला पिन है वो आर्डिनो यूनो के डिजिटल पिन नंबर 2 से कनेक्ट रहेगा, और जो पीआईआर सेंसर का डीसीसी जो है 5 वोल्ट से कनेक्ट रहेगा, और जो ग्राउंड है वो ग्राउंड से कनेक्ट रहेगा। और रिले का पिन नंबर 1 जो है वो डीसी से कनेक्ट रहेगा, और जो पिन नंबर 2 है वो ट्रांजिस्टर के कलेक्टर पिन से कनेक्ट रहेगा। और ट्रांजिस्टर का जो इमीटर पिन है वो ग्राउंड से कनेक्ट रहेगा, और जो बेस पिन है वो पिन नंबर 3 से कनेक्ट रहेगा। और जो रिले का 3 नंबर पिन है वो मोटर से कनेक्ट रहेगा, और चौथा पिन खाली रहेगा, और पांचवा पिन इनपुट रहेगा, और एक मोटर में डायरेक्टली न्यूट्रल कनेक्ट रहेगा। तो जैसे एसएमपी सप्लाई देंगे तो आर्डिनो हमारा चालू हो जाएगा, सारा सर्किट ऑन हो जाएगा। जैसे ही ह्यूमन जाएगा पीआईआर सेंसर के पास तो वो सेंस करेगा और आउटपुट प्रोवाइड करेगा, जिससे आउटपुट माइक्रो कंट्रोलर से उसे आउटपुट निकलेगा, तो ट्रांजिस्टर को स्विच करेगा, और ट्रांजिस्टर जो है रिले को स्विच करेगा, और रिले मोटर ऑन करा दीजिए जो प्रेशर पंप है। नेक्स्ट स्लाइड। तो हमने आर्डिनो यूज़ किया, आर्डिनो का सॉफ्टवेयर यूज़ किया है, तो arduino.cc वेबसाइट से डाउनलोड। इसमें मेन आपको बताना होता है कि क्या क्या लगे हैं, किस पिन से कनेक्ट हैं। फर्स्ट 2 लाइन में हमने वो बताया है, फिर उसके बाद बोर्ड सेटअप आ गया है, जिसमें हमें ये बताना था आर्डिनो को कि जो कंपोनेंट है इनपुट है या आउटपुट के कंपोनेंट है। फिर उसके बाद हमारा वर्ड सेटअप आ गया। तो सब वो हैं, तो बार बार हमें रिपीट कराना। इसमें जैसे ही पास कोई ह्यूमन जाएगा वैसे ही आउटपुट जो है एयर सेंसर का वो हाई हो जाएगा, जिससे हमारा रिले ऑन हो जाएगा और सैनिटाइज हो जाएगा। इसमें हमने टाइम लगाए हुए है 40 सेकेंड का, और एक डिले भी लगाया है। जैसे ही ह्यूमन निकल जाएगा वैसे ही हमारा सेंसर लो हो जाएगा और हमारा आउटपुट बंद हो जाएगा। अगली स्लाइड।
Thank you, Ashish. Now we will discuss about the design aspect. As we all know, we are dealing with pandemic, and so as the rise of prices in every there. So there's in this project we are planning to minimize the loss of sanitization. So we have designed, so we have modified the designs. So if we look about, if we know that there are underground cables and the transmission line, the transmission line are out forward, and these underground lines are which are not visible. So those things which are not visible looks good. So in that case, if we use immersible pumps, pressure pumps, that will look good as per the design. And one thing is that where the immersible pump has to be immersed in certain level, beneath which we will not get the perfect pressure. So for that, if we look this, if we have this regular tank, then there will be lots of sanitization more. And if we have this particular design, which is zigzag design, there you can see there is a low, there is a level, less level than the previous one, which will decrease the loss of sanitization. The second design aspect is the area of dispensing. If we have there is a two dispensing uh, approach. First is the plus one and second is the cross one. The plus one will sanitize in vertical and horizontal direction, and the cross one will sanitize the person to the most extent, because it will cover all the direction, and it will give more sanitization. Next, advantage in recent studies. If we look to the advantages, easy to install because it has less component and they are all cheap as well. So it has average to minimum cost, and the sanitization is 80 to 90%. The next thing is the recent sanitization advancement. As we know, the sanitization is alcohol based, but there is a developed sanitization was developed by the IIT team of IIT, and they name it Drug Safe, which has the nano copper infusion. As we all know, copper surface is something which in which corona cannot exist for long. So they use this technique to make this sanitization, and it provides 24-hour protection against the all type of viruses and microbes. And about the reference, we have took it as AICT Private Limited, which is a learning space. And this is all about our projects. And thank you for giving us opportunity.
Thank you, Amit and team members, for the nice presentation. Now I would like to invite our next participant, Shweta Mishra group, and Shweta Mishra, Shweta Thakre, Tasha Mishra, and Yashika Vyas. So, presenter, please share your participant your presentation and explain it, please. Shweta, yes. Your screen, yes, okay. Shweta, put it in, yes, now it's fine, okay.
Can I start, ma'am?
Yes, you can start, please.
Yes. Good morning, everybody. Myself, Tashi Mishra, and I'm here to present my PPT with you guys. So, my team members are Shweta Mishra, Shweta Thakre, and Yashika Vyas. So, let me start it. Shweta, please change the slide. So, these are our contents of our solar electric car topic. That are introduction, what is solar car, history of solar car, components of solar car, working principles, and advantages, disadvantages, its applications, limitations, and conclusions. Next slide. This is our abstract. If I explain my abstract, it says that uh, as we all know that the usually cars which run on our roads, these are basically diesel cars and petrol cars, which are polluting. And as you know that petroleum, coal, and these all are non-renewable energy. So these are actually non-renewable sources of energy. So nowadays, people are taking more interest in renewable sources of energy as because they are present in abundant quantity in the environment, and these are non-polluting as well. So next slide. Next slide. Yeah, introduction of solar car. Solar car is a land transport is powered by solar energy by the use of photovoltaic cells. As you know that solar car in basically solar car we use photovoltaic cells, or we can say that we use solar panels which converts the solar energy into electric energy, which is again non-polluting in nature. Next slide. These are our solar panels, as you can see. Next slide. The history of solar car is that the first car which was invented by William Jacob in 1955, he used 12 photovoltaic cells which were of size 12 inches, and he called this car as Sun Mobile. These are our components, which are solar array, power tracker, electric motor, controller, phases, batteries, and wheels. Next slide. Solar array, as I have previously told you that solar array are those things which convert the solar energy into electric energy. Power trackers, we use power trackers also for solar cars. Next slide. Electric motors, generally we use DC motors in our cars. Speed controllers basically used to control the speed of the car. These are basically connected with the wheels and the motors. Battery, again, batteries, we use battery in solar cars because as we know that we get solar energy in the time of daytime only. So for night time, we can store this solar energy in batteries, and after that we can operate it at night also. Next slide. Phases and wheels, these are basically the building structure of our car. It provides support to our car and wheels. Next, this is the circuit diagram of our solar tracker, which will solar power tracker, which will be used in our solar car. Next, this is our circuit diagram of the solar car. Next, working principle is again the same. So the solar panels will convert the solar energy into electric energy, and it will pass it to the motors and then to the wheels. Next, working diagram. Next, advantages added. It reduces pollution, reduces energy cost, reduces noise pollution. Next, the disadvantages, it has high initial cost. As you know that we use solar panels and these solar trackers, motors, batteries, these are quite high in cost. So the initial cost is high and less speed than regular cars. Limitations is that solar energy technology still remains a costly alternative source. Still, we know that nowadays solar we are working on solar cars, but still there is not a complete car which we can launch in the market, which can be used commercially. So still we have to work a lot in this. And solar energy is only useful when the sun is shining. As I said, solar energy is only be used as in daytime only. So still we have to take certain kinds of we have to do certain kinds of inventions, and we have to develop the techniques so that we can make it more commercial. Next, these are its applications. Next, conclusion is only that the solar car is the future technology. It will be absolutely, it will bring a revolution in the field of our cars and everything, our automobile. So it's a very good technology which uh, is very useful for the future. Next, these are our references. Thank you, ma'am.
Okay. Thank you
Thank you, ma'am.
for the nice presentation. I hope I hope this presentation would increase your communication skills, also presenting skills. Also, if you are doing very good. Now, I would like to request next participant for the presentation. Mayank Minkal, Rambant Nayak, Jyoti Mandloi, Chaturvedi for the group. Presenter, any one of you, please share your presentation.
Ma'am, screen is visible?
Maximize the screen. Yes, it is visible. You can max. In view has been shared. You can go ahead.
Okay, ma'am. Good afternoon, everyone. I am Mayank Minkal and my team member is Rambant Nayak, Jyoti Mandloi, Akansha Chaturvedi, and Ankita Singh. And our project guide is Rajendra Mohare, sir. And our project is prepaid energy meter using Arduino Uno and GSM technology. Now come on abstract, it is realized that one of the defective subsystem adding to the tremendous budgetary loss in power supply company is the conventional metering and channel framework. Mistakes get presented at each phase of charging the energy rate, similar to the blunder with conventional meters, reading errors by human while noticing the consumed energy, and blunder during the presentation of paid and due bills. Our proposed design embedded with Arduino Uno and GSM technology is advancement during conventional energy meter, which enables consumers to effectively manage their electricity usage. The system performance is good with the acquired result, and earlier charging will undoubtedly get rid of issue of unpaid bills and human mistakes in meter reading. Now, introduction of the prepaid energy meter. Prepaid energy meter is a good concept in which you can recharge its balance like we all do in our mobile phones. In this project, we are building an automated system by using Arduino Uno and GSM module. You can recharge the electricity balance through the system just by sending a SMS. It also disconnects the home supplies connection if there is low or zero balance in the system, and this system will read the energy meter reading and automatically send some updates to users home phone like low balance alert, cutoff alert, resume alert, recharge alert, and daily energy consumption. The component used in prepaid energy meter is Arduino Uno, GSM module, LCD, analogous electricity energy meter, octocoupler, register, port, connecting wires, bulb and holders, SIM card, power supply, and mobile phone also. Now comes on working. The working of prepaid energy meter is if available balance is greater than 15 rupees, then Arduino turns on the electricity of home or office by using relay, and if the balance is less than 15 rupees, then Arduino sends a SMS to user phone regarding low balance alert and requesting to recharge soon. If the balance is less than 5 rupees, then Arduino turns off the electricity connection of home and send SMS to the user's phone to light cut alert and requesting to recharge soon. This is our block diagram This is a circuit diagram where we use Arduino Uno LCD optocoupler, GSM module, and energy meter. The advantage of prepaid energy meter is first, prepayment of electricity bill, no billing error, customer will be responsible for disconnection, no need of extra staff for meter readings. In conclusion, the advancement in power distribution system is non-stop process and new technology is always in process. In this project, an Arduino and GSM-based smart prepaid energy meter has been proposed. Units are purchased by using GSM technology and those units are decided according to the electricity user. This project presents a single phase energy meter for domestic consumers with prepayment billing method. This significant prepaid standpoint is the capacity of this system to update the current conventional meter into a smart prepaid meter with a connection of Arduino and GSM. These skills are need of totally supplant the energy meter. Cost is the main important factor of this work, which is quite high, but will reduce from 3 to 4 times of implementation of this project. Nowadays, as supply companies need labor for meter readings, after implementing this, there will no need of so many meter readers and lots of money will be saved. Thank you, everyone.
Now the next participant is Mr. Sonukumar from Chennai. I request Sonu to please share your presentation.
Yeah, good afternoon, everyone. Thank you, ma'am. I'll just share. Is my slide visible?
Yes, it is visible. You can go ahead.
Yeah, thank you, ma'am. So I'm going to present on the topic design and development of PWM-based charger for wind energy system using multi-sim simulation. So first of all, I'll give intro about wind energy system. So as we know that wind energy system, in wind energy system, we generate energy from wind, in which we generate the energy. We first extract the energy of the flowing air through the wind blades and it is converted to mechanical energy. Then through wind generator, it is converted from mechanical to electrical energy. And then generally we have in this block diagram, you can see it in wind turbine, we have wind generator. After that, generally we have wind generator, generally AC for most of the system. We have some DC generator also. So for in general system, we have to convert this AC to DC. For that, we use wind converter, and then a wind charger is used, which will control the flow and which will reduce this. Generally wind converter voltage will be also high voltage. It will be higher than the battery voltage, and battery generally what we use in the system is 12 volt to 24 volt. So for bringing up to that, wind charger is being used, and then from battery, and most of the uses we use AC load. So inverter is being used for converting from DC to AC. And there are some of the figures like there are some renewable energy sources like solar and wind, which are the best options for India as well as for globe. Like you can see it in wind is 622 gigawatt is installed capacity, and it is 2019 data, and it's like last year we have generated around 1,429 terawatt hour, and it is contributing around 20% of total production from renewable energy side. So wind is a very important source of energy. So developing a suitable wind chargers is a very important, which will increase the power transfer efficiency, and which in turns will be helpful in generating more energy and more supplying more power to the load. So this is my proposed system. in which you can see it from wind turbine, wind generator, which I have already mentioned, then wind converter, and here we have wind charger, which is so in these here I have seen the main diagrams in which like the power will flow through the MOSFET is switching device, and it will go to battery, and in between it will be controlled by the timer ICs for controlling the duty ratios and other things that I will show in next diagram. And then this is my circuit diagram of my proposed wind chargers. Here you can see the input is from this side. Input is coming from wind converter, which is a DC voltage, and it will vary from 0 to 46 volt in my system. So based on the wind generator use and the wind converter use, the voltage will be having different values, and then it's for charging the battery. It will pass through the MOSFETs. Here we have used two MOSFET combinations. If the power is high, more current will be flowing, then more number of MOSFETs can be used in parallel for my application. Since the maximum power is around 140 watt for my system, so I have used only two MOSFETs, which is able to handle that much high current. And then for supplying power to the timer IC, we have reduced the voltage since it cannot accept more than around 15 volt or 18 volt. So we have reduced this high DC voltage to lesser voltage using the voltage regulator ICs. We have done it in two stages. One is 7818 IC, through which it will reduce the voltage to 18 volt, and then again 7812 IC, which will reduce this voltage regulator IC will reduce to 12 volt, and then it can be given to the timer. Here I have used some of the capacitor resistance, which will decide what will be the pulse width and what will be a time period for that. And the output of this timer IC will be a square wave pulse, and for amplifying that one, I've used the transistor, which will boost it from 10 volt pulse, around 12 volt pulse to 24 volt pulse, and that will be applied at the MOSFET gate. Here you can see it. And when the pulse is applied, that time the current will flow from the wind converter to the battery. And when no pulse is there, that place it will be off. So it will control the flow of current. When the battery is charged, on that condition it will on that condition no pulse will be applied off at here gate, so that no current will flow from wind converter side to the battery, and it will stop the charging. So battery voltage will be maintained within the limit. Like for my battery condition, it should be maintained between 21.4 volt to maximum 28.8 volt. It should not exceed that one. So it is able to maintain the voltage, and also the charging flow rate is steady. So here you can see the major components. Just I'm showing. This is a diode, which will a 12 ampere diode, which will restrict the reverse flow of current from like it should not go flow in backward direction from like battery side to the wind side. So it will block the reverse flow. Then other components are here, like earlier diagram I mentioned. It is ICs 7818 and 7812 that I am showing here. This is 7818 IC, 7812 IC. Then this timer IC and the switch transistor I have used BC547, and this is the MOSFET, which I have used two MOSFETs in my circuit. So for what approach I have followed for designing this wind charger is first simulated in multi-sim software and drawn the specifications what value will be suitable for my application, and based on that I have developed the hardware circuit. So that's what I'm explaining here. Here you can see the gate pulse which I have done. So the gate pulse will be the pulse which is generated from timer IC, which will be of this. It will be this waveform. From timer IC, it will come around 12 volt, and after passing through the transistor which I have used in my circuit, it will be around 24 volt, or so that kind of gate pulse will get it. and this is applied at the MOSFET gate terminal, and when the pulse is available, at that time the current will flow from the MOSFET on terminal, which is connected from the wind converter, and it will flow to the battery. Then here you can see it. This is the voltage available at the MOSFET source terminal, which is connected with battery. So this is the output of the wind charger. Here you can see it is around 24 volt. It can be adjusted also. We have variable resistor. You can see it in the circuit. Using that, we can slightly modify also this one. So this is a constant DC voltage which we can get it. If the wind speed is higher than 2.5 meters per second, then we are able to get the output voltage. So this is hardware circuit which I have developed. Here you can see this is in the side you can see the diode which will block the reverse flow, and MOSFET we have used with this one heatsink, and this is our timer IC. Another is connecting devices, resistors and capacitors, and this one big you can see it is this is a heatsink, so that it should not heat, and the components should not burn like MOSFETs and other things. It should not temperature should not rise much. For that is the big heat sink. And this is my experimental setup. Here you can see it from the wind turbine. It is coming. Here you can see this is a 7-inch stamp wind turbine, vertical axis wind turbine, and here down we have wind generator, and then this is wind converter, and this is wind charger which we have developed, and this battery we have used for charging. So wind speed. So here I am showing a wind speed for 1 day. So for 24-hour period I am just showing. So during this period, wind speed has varied from 0 to 5.55 meter per second. So wind speed will be varying too much. It will be changing quickly. Sometimes it will be very high, sometimes low. So so this is the wind speed pattern. And similarly, when the power will be generated only when the wind speed is higher than 2.5 meters per second. If it is lower, then no power will be generated. Here wind and voltage what is coming from the wind. So this is the voltage which I am showing. This is available at the wind converter. This is DC voltage level which is available. So it has varied for the wind speed which I have shown earlier. It is varied from 0 to 46 volt. So that only I have simulated in the my simulation study. Then this is experimental. This is the I have tested the hardware setup, and to find out the efficiency, how much will be the efficiency. So here you can see it, in both the input side and output side of wind charger, we have measured the voltage, current, and power, and we came to know that the efficiency is around 84 to 85% for my developed PWM based wind charger. And this was the cost in developing the wind charger which I used. It is having like diode, voltage regulator, ICs, resistors, capacitors, transistors, MOSFET, and the general purpose board which is used for soldering. So it is coming around 430 rupees. So I would like to say highlight some of the things like this wind charger is capable of like blocking the reverse flow. It will not, no current will flow in backward direction. Also, it is able to lower the voltage from the wind converter, and like reducing the voltage and increasing the current, so that the more power will be transferred from the wind converter to the battery. And as I have earlier shown in my result, like the wind speed which has varied from 0 to 5.5, it shows the wind converter is generated 46 volt, and we are able to charge the battery. And the development cost which I have already mentioned is 430 for this one. So further what can be like further increasing the efficiency of this wind charger, and also increasing other features like now I'm working on making implementing the display also, which can display all these parameters: voltage, current, power, wind speed, and other things with this. And also having other protection circuits like over voltage protection, under voltage protection, and IoT enabled feature also I'm going to implement this. So that is my feature work that I have not shown here. These are the references which I have used. And I would like to thank my guide, Obed, and the director of my lab for providing me facility for conducting these studies. Thank you.
Thank you so much, Sonu, for the nice presentation. That's
Thank you, ma'am.
knowledgeable for all the participants. I thank you all the participants for this first session. Yes, and we'll be having a two, and I hope we'll be joining at 1:55 or around 2. We'll be having our next keynote speaker with us from 2 to 3, and after 3 the session second presentation schedule will held. So I think we are ending up for the presentation first session now. We'll be gathered for YouTube streaming. Will be there listening to the speaker from 2 to 3, and 3 p.m. onwards this link will be again active for all the participants for the rest of the presentation. Thank you so much all the participants for the excellent presentations and your active participation and the team members who are thank you all of you. We'll be joining again at 2.